Hello everyone, in this video we will discuss cube counting. This is a very interesting topic and a fun topic to learn. Questions from this topic includes counting of number of smaller cubes in a three-dimensional figure that is given to us. Basically a three-dimensional figure will be given to you which will have smaller cubes in it. You have to count how many smaller cubes are there in this three-dimensional figure that is given. Let's get started. Let's first discuss a few concepts about cubes and cuboids because this will be very helpful while solving questions from this topic. So this is a cuboid and this is a cube. These are three-dimensional figures. They have length, breadth and height. That's why they are called three-dimensional figures, right? They have 3 dimensions. So length, breadth and height. In a cuboid, all these 3 will generally be different. In cubes, the length, breadth and the height will be the same. That is the difference between a cube and a cuboid. Till now, whatever we discussed was the basics. Now let us look at the actual questions that can come from this topic in the examination. Look at the first figure here. Count the number of cubes in the figure. Very easy to count, right? This is 1 cube, this is 2. This is 3 and there is actually one cube underneath this one, this number 3, right? The cube number 3, there is a cube under that which is hidden. So totally how many cubes are there in this figure? There are 4 cubes in this given figure. This is very easy to count. Look at this figure. How will you count the number of cubes? So this is number 1, 2, 3, 4, 5, 6. This is 7. There is a cube here, right? 7. 8, 9, 10, 11. There are 11 cubes in this figure. This is also very easy to count. But there is also so I have counted the cubes here manually. There is an alternative approach in which I can find out the number of cubes in this given figure. Let's discuss that also. For this problem, solving it manually is easier to do, but this method that we are going to discuss now will be helpful for you when you are trying to solve complex questions from this topic. So here, let us go layer by layer. See, this is the first layer, right? In this figure, this is the first layer or the bottommost layer. Now, in the bottommost layer, the top of which cubes in the first layer are you able to see? If you see, I am able to see the top part of this cube. That is the first cube in this bottommost layer where I am able to see the top part of the cube or the top part is visible. Similarly, look at this cube. Here also, I am able to see the top part of the cube. And this also belongs to the bottommost layer. Again, for this cube also, I am able to see the top part of the cube. And this cube also belongs to the bottommost layer. Again this cube. Also I am able to see the top part and that is also belonging to the bottom layer. So how many cubes are there in the first layer or in the bottommost layer whose top portion or top face I am able to see? There are 4 such cubes. So I just write 1 multiplied by 4. Now let's go to the second layer. In the second layer, tell me how many cubes are there whose topmost part I am able to see or whose top face I am able to see. This is 1 cube whose top face I can see in the second layer. This is another cube whose top face I can see in the second layer. So there are only 2 cubes in the second layer whose top face I am able to see. So there are only 2 cubes, so I just write 2 multiplied by 2. Now I have one more layer which is the third layer. In this third layer, how many cubes are there whose top face I am able to see? There is only 1 cube here. There is only 1 cube whose top face I am able to see. So I will just write here 3 multiplied by 1. Now the total number of cubes in this figure given here is nothing but 4 ones are 4, 2 twos are 4, 3 ones are 3. Add up all this, what will you get? You will get 4 plus 4 is 8, 8 plus 3 is 11. That is the answer that we got previously also. So, one way of solving questions from this cubes is trying to manually add the number of smaller cubes given in the figure. For figures which are very complex, that will become difficult. In that case, what is the method that we discussed? Go layer by layer. First look at the bottommost layer and see how many cubes are there whose top face, this is the top face of this cube, right? How many cubes are there whose top face you are able to see? Count that and multiply that with 1. Then go to the second layer, and in the second layer again find out how many cubes are there whose top layer you are able to see. There are 2 cubes here, so multiply that with 2. Then go to the third layer. Again see how many cubes are there whose top layer you are able to see. There is only 1 cube. So do 3 multiplied by 1. Add up all these and that will give you the answer of the total number of smaller cubes present in the given figure. Let us discuss one more question so that this concept or this method that we discussed is clear to you. Look at this. So let us try out using the method that we just learned. Let us first see how many layers are there in this given figure. How many layers are there? This is the bottommost layer. Correct? This is the bottommost layer. First layer, second layer, third layer and fourth layer. There are 4 layers of cube here which are arranged. So I will have to do 1 multiplied by some number, 2 multiplied by 3 multiplied by 4 multiplied by. Why am I writing it like this? See, for you to understand that, in the previous question also I wrote here 1, 2, 3. This represents the layer. Which layer I am considering? This was the first layer that I considered, right? In the first layer there were 4 cubes. In the second layer there were 2 cubes. In the third layer there was 1 cube. So this represents the layer. Okay. Now in the next question or the question that we are currently solving, there are 4 layers. So obviously I will be writing it like this. So that's why I am writing this 1, 2 and 3, 4 here in the beginning itself. Now let us look at the first layer. In the first layer, how many cubes are there whose top face is exposed? There is only 1 cube like that. This is the only 1 cube whose top face is seen. So I will just do 1 multiplied by 1. Now let's go to the second layer. In the second layer, how many cubes are there whose top faces is seen? So this is 1, this is 2 and this is 3. There are 3 cubes whose top faces seen. Let's go to the third layer. In the third layer, how many cubes are there whose top face is seen? 1, 2, 3, 4 and 5. There are 5 cubes whose top face is seen. Let's go to the final layer, that is the fourth layer here. In the fourth layer, how many cubes are there whose top face is seen? This is 1, 2, 3, 4, 5, 6 and 7. There are 7 cubes whose top face is seen. So what will be the total number of cubes in the given figure? The total number of cubes in the given figure is nothing but 1 1s are 1, 2 3s are 6, 3 5s are 15, 7 4s are 28. Add all of these. What will you get? 6 plus 1 is 7, 15 plus 7 is 22, 22 plus 28 is 50. Totally there are 50 small cubes in this given figure. The answer for this question is 50. I hope this method is clear to you. There is another way of solving this question. Let us discuss that also. This given figure is actually a 4 by 4 by 4 cube, out of which some smaller cubes have been removed. Now if this cube was complete, if this big cube, that is the 4 by 4 by 4 cube was complete, how many smaller cubes would have actually been there in this given figure? There would have been 4 multiplied by 4 multiplied by 4, or there would be 64 cubes actually. Now out of the 64 cubes, how many cubes have been removed? So let's find out how many such cubes, smaller cubes were removed. Now if you look at this space here, right, this space here, ideally there should have been 3 cubes on top of this cube. Correct? There should have been 3 cubes on top of this cube so that the bigger cube was complete. There should have been 3 cubes here. Similarly, if you consider this cube here, this space here, there should be 2 cubes actually on top of this, one in this layer and then one in the next layer. Similarly, here also there should be 2 cubes on top of this to complete the big 4 by 4 by 4 cube. Here also 2 cubes would be there. Here 1 cube should have been here, here also 1 cube should have been here, 1 cube should have been here, 1 cube should have been here and 1 cube should have been here. So totally how many cubes have been removed? From the 64 cubes we have removed 2 plus 2 plus 2, that is 6, 6 plus 3, 9, 10, 11, 12, 13, 14 cubes we have removed. So out of the 64 cubes, 14 cubes are removed, or there are only 50 cubes now. This is the alternate way of solving the question. Whichever of these methods is easier to you, follow that. I hope the concept that we discussed in this video was clear to all of you. If you have any doubts, please do let me know in the comments box. I'll be happy to help you. Thank you.